In this video, I want to talk about variables in C#. In the last video, we built our first application together. It was a Hello World application. We learned how to put some text on the screen. In this video, I want to level up the complexity of what we're able to build by talking about variables. Variables are one of these pillars of programming that once you understand, you're basically never going to write a program that doesn't involve variables in some form going forward. So variables allow us to store and manipulate data. What does that mean? That could be that we need to store the player's name somewhere so that we can refer to it, so that when the application boots up, it says, welcome, Mike. What would you like to do, Mike? That's one form of data. Another form might be that we're asking the user a question. So maybe it's a trivia question. It has A, B, and C. We want to know what their choice is. So we ask them and we store their response in a variable. And then we're able to check whether that variable is right or wrong. So what is a variable then? I think that one of the easiest ways to picture it when you're starting out is that it is a labeled box in the computer's memory. So I'm going to draw a little box graphic here, put a label on the front. And let's say that we're building that trivia application. We want to store the player's score somewhere. So I'm going to put a label on this box, score, and then what we're putting into this box is a value that represents the player's current score. So when the application boots up, maybe 0 is in that box. And what happens is that anytime we use this word in our programming, in our C# code, score, the computer is able to look up the value that's in that box. So when we say console writeline score, we can pull whatever's in here. And since 0 is in here, it would print out 0. But what we can also do with variables is manipulate them over time. So it might start out at 0, and then when the player gets something right, we can increment that to 1. And when they get something right again, increment that to 2. So you can think of variables as kind of like labeled boxes in the computer's memory that hold information. One of the added wrinkles here is that each box you create is only big enough to hold a specific type of information. So we're going to have to start talking about data types. And I will pull up a Microsoft documentation page for us in a second. But just to give you some examples, here's our score. Here's what the line of code might look like to create that score variable and set it equal to 2. So the box here that we're using is an int or an integer. It is just for whole numbers. So we can't store 2.5 in there. We can't store 0.5, 0.25, anything with a decimal place in there. It's only for whole numbers. But we have another variable type. So maybe we have a variable here that we want to store, which is how long it took the player to respond to a trivia question. So maybe we'd say time elapsed. And maybe it took them 0.25 seconds to respond. And we'd factor that in somehow to our game. So double is a variable type that can hold numbers that have a decimal place. So if we're creating a variable and it's a whole number, we'll reach for something like an integer. And if it's something that has a decimal, we'll reach for something like a double. There's also a Boolean, which is a thing that can hold one of two values, true or false. So maybe we want to store whether the player was right or wrong. So we can say, was player right equals true. Each of these is a different variable, so you can think of them as different boxes in memory, and they are different types. So they're different size boxes that are designed to hold that specific type. So a Boolean here is designed just to hold true, false. We can't put a number in there. That's sort of like not technically true. They're a little bit, I'm being a little hand wavy here with the concepts, but this is a good place for us to start thinking about types. So let me pull up a documentation page here. I will link this in the video. but this is the built-in types to C#. So here are the types of variables you can create, the types of those boxes. So we can see bool here for Boolean. We can see int here for integer, double for our double variable. And if I click on any of these, there are actually multiple types for, say, storing a whole number. And we can see a table of them here. So integers have this range from negative 2 billion something to positive 2 billion. You can put those kinds of numbers into that box. But as soon as you need to store something that's bigger, like 10 billion, you can't store that in a regular old int variable. You have to choose a different data type. And if you look down this list to look at the range, here's one, a long, which can hold a lot more than an int. So that would be what we would reach for if we have a really big number that we have to include in our code. You can see the range varies here. The other thing that varies is the size. So you can think of the boxes as bigger or smaller. And so for, say, a byte variable, which is a whole number between 0 or 255, it takes up 8 bits in memory versus an integer, which takes up 32 bits in memory. So when you're thinking about the type of variable you want, when you get further in your programming career, you'll think, what is the optimal type for this? Like, you want to be as efficient as possible with your choice of variables. If you have a really small variable that's only going to be 0 to 100, choose a byte. If you have a variable that's going to exceed that, maybe you choose an int. Context of this class, we're probably going to reach for int for almost every situation to just make life easier. And same thing if I go back and look at double, there are a couple of types here. There is a double, which has this precision, and there's a float, which has this precision, and you can see the size is different. We're basically going to be reaching for double for holding our numbers that have floating point. Just be aware that there are also other data types. So for instance, if you do a lot of Unity work, you'll see floats all over the place. And we may introduce decimal later when we're working with currency math. It's enough concept. Let's dig into writing some code. So what I'm going to do is go ahead and open Visual Studio here. And I'm going to create a new project. I'm going to make sure that it's a console app. And I'm going to store it on my computer where I've been storing the rest of these. So I'm keeping them all together here. Call this variables, and then hit create. So we got our basic template here, hello world application. What I want to do before I even start is remember that our application is basically whatever we put into this main function here. Starts at the top of this curly bracket, runs every statement that it finds, and then when the end curly bracket is reached here, we're done. The application closes. So with my current setup here, if I hit play, console window is going to flash open for a split second, disappear. So what I'm always going to want to do is add in a read key and add in a little message to let the user know what's going on. So press any key to exit. So there we go. The window pops open, stays open until we press a key. And we can clean this up a little bit, make it a little tidier by changing the title, or not tidier, more polished here. And let's say variables demo. And if I print it out, we get this little header at the top that has this text that we just inputted. All right, charging forward, let's get rid of the hello world. We're done with that. What we want to do is create our first variable. So let's say that we are creating some kind of game where we need to store the player's score. And we have decided that the player's score is always a whole number. It's never going to have a fractional component, a decimal component. So we're going to choose an integer. And we will set this, maybe the player's score starts at 0. So we'll say it's equal to 0. We have our variable. Don't freak out about this green squiggle here. So this is not an error. The red squiggles are errors. The green squiggles are warnings. They're telling us here we've created a variable and never used it. And if you have a variable that you've never used, it's basically like it didn't exist in your code. So it's warning you that you may have something wrong. So it's fine for us to ignore this for now. We've got our player score variable. It's an integer. Let's go ahead and use it. So I could console.writeline player score. And as soon as I use that variable, that squiggle's gone. So when I run this here, we can see our variable printing out and then press any key to exit. Not super helpful, but maybe what we'd want it to say is your score : 0. And what we can do is change our writeline here. Your score is : What we're doing is creating what's called a string here. We are concatenating it with the player's score. So what we're basically doing is saying, take these characters and then shove the number here at the end of the string. And if we run it, we can see your score is 0. So let me add a comment. We can concatenate a string and a number together. We can also do math with our variables here. So we can also do math. So we could print out the score +1 to sort of picture what would happen if we got another point. So we can see the score printed out here as 0, and then we got 1 printed out on the next line. A little note, this didn't actually change the value that we stored in player score. This is just doing a little bit of math to add whatever's in that variable +1. We'll look at adding to a variable later. What I want to do is take a step back, go back to our whiteboard, and diagram this out so that we can label the parts of our variable here. So when we create a variable, it's going to look a lot like this many times when we create a variable, so that we can kind of label the parts here. We have, whoops, there we go. We have our data type for the variable. So what type is that box? Then what we have here is the identifier, or the variable name. We have the assignment operator. And then what we have here is the value that we want to store inside of our variable. So in this case, that value is an integer value. We're saying take the integer number 0 and put that into our player score box. So if we wanted to create a variable of another type, we're just going to, change the type that we put here. So instead of int, maybe it's double. And then the value that we put in there, we can put a double value in. So if we wanted, we could refactor this and say double player score equals 10.5, and that would be valid. Before we add any more to our code, I do want to point out variable names. Those are generally up to us. We can pick a lot of different things for storing our variables. What we're going to use in this video is called Camelcase for the convention. And so Camelcase is where you shove all the words together. The first word is lowercase, and then every word after the first word is uppercase. So like player score, P is lowercase, score is uppercase. There are no spaces. And you can't have spaces inside of your variable name. So if we tried to do int player space score, that would give us an error in our code. So we want to do Camelcase variables that are short and descriptive. So some examples like player score, good name. It describes what the data we're storing is. Or num items to indicate how many items the player has. Decent variable name. It's short, it's descriptive, it's Camelcase. Some bad variable names. If we created something called that silly thing, it's sort of short, but it has no descriptive value. It does not tell us what the variable holds. So we don't want to do something like that. Similarly, like a variable called a, really short, but again, not very descriptive. And generally, we want to steer clear of doing wonky things with our casing. Like if instead of using Camelcase, we did some weird convention of every other letter is uppercase. I'm even having trouble writing this out. There we go. That's really hard to read, right? Num items. So we kind of want to stick to our conventions. So Camelcase and short and descriptive. All right, let's flip back to the code, look at a few more things together. So I mentioned doubles. Let's go ahead and throw a double in here. Like maybe we're creating an application where we need to store the cost of some item. Like we're building a RPG item store, or we're building an e-commerce site, and something is $10.25. All we have to do is, like our formula here, start with the type. So it's double, we give it a name, and maybe I'll refactor this to be item cost, and then we give it a value over on the right-hand side here. And then we could print out console.writeline, the item's cost is item cost. Again, we're using concatenation to take our string that we're creating here, the sequence of characters, and just jam the item cost onto the end of it. So we've got the stuff that we had from before printing out, and now we've got our items cost. I'll throw a little bit of an added wrinkle here. With currency, we'd probably reach for a decimal, but don't worry too much about that at this stage. I want to show you a couple of mistakes that we can make. So one is that if we create a variable, let's call it bad int, that is an integer, and we try and store a number that has a decimal place in it, we're going to get an error. It's going to tell us that this thing here, it's telling us cannot implicitly convert from double, which is 44.5, to integer. We've said that our variable size, that box, is an integer. So we can't put a double in there. It's giving us some hint that there's a way to convert. We're not really worried about it at this point. At this point, we just want to match the type that we have here to the information that we're putting into that variable. So let's say, don't do this, type mismatch. Another thing that we could do that might be bad would be really big num. And then I'm just going to hold 0 down for a while. Remember that integers can only hold things from -2 billion and change to +2 billion. So I've just tried to put a number that's really big inside of there, and I'm getting an error. It's telling me that integral constant, so that integer that I'm using, is too large for an integer. So don't do this. Int can only hold numbers of a certain size. Here I'm just commenting those out. I'm going to leave them in here as sort of annotated things so that we can refer back to them later. Let's introduce a third type of variable here. So I've mentioned this idea of strings before. a string is a series of characters that we're surrounding by double quotes. So integer is for whole numbers, double is for numbers that have a decimal component, and string is when we want to store a series of characters. So here I want to store a quote maybe. And one that I like is perfect is the enemy of good, which just means that striving for perfection can sort of paralyze you and prevent you from actually just making something that's decent. It's something that I try and keep in mind often. So we created that quote, and then we can print it out. Console.writeline. Here is a quote for you. And if I run it, we should see our integer printing out, our double, and here's our quote. I want to show you a few more things. So what I'm going to do is zoom around a little bit, and I'm not going to put code down here. I'm going to put it in a few other places. So one, let's say that we're in a situation where we want to print this out. We want to put this title inside of the title bar, but we also want to print it out on the screen. Not a problem, you say. We just do this, and I'm going to copy and paste this code in both of these places. Great. But as soon as you want to change this, you now have to edit it in two places. So one of the useful things about variables is that we can declare a value once and then use it in multiple places. So let's say variables can be useful for info that you need in multiple places. So we'll create a string title, and we're putting that title of our application into that variable so that we can then just say, okay, console title, you're equal to our title variable, and when the application boots up, let's just print out that title variable. So there we go. We got it printing out, and we've got it up at the top here in our console's title bar. And the value here is that, okay, I want to refactor it. I want to get rid of that exclamation point. I now only have to edit it in one place because we're referring to that variable here. So it's going to automatically take the latest value and use it in the title bar and in the console window. So there we go. It's updated here and here. So that's one use of variables. Another is that variables enable us to work with user input. So let's say we want to customize our application so that it asks for the person's name, whoever's using the application, and welcomes them by name to the application. So we're going to print out a message. We're going to say, what is your name? On the next line, what we can do is create a new variable. It's called name. And instead of setting it to a specific value, these are called literals when we type in a specific number value or when we type a string value. So instead of typing in like the specific thing here, doing Mike, which wouldn't be very useful because the application would always think the name is Mike, we're going to use the console readline command to ask the console to read a line of text. So whatever the user types is going to end up in our variable here. And then we can console.writeline, welcome to my silly app. And if we run it here, asking us for our name, I'll type in my name here, and then it's going to welcome me to the app, and the app's going to kick off and run. And if I were to run this again and say my name is Helene, that is going to print out that new user's name. So anytime this runs, our code can now pull the actual user's name and use it in the application. I want to use some of our console knowledge from last time. So we saw that console Writeline prints out the text and then moves the cursor to the next line so that anything that's typed shows up on the next line. Console.write doesn't do that, moving to the next line. So if I do what is your name and add a space here, that's going to allow me to have the question here and the answer right next to it. Cool. And I want to extend this so that there's a period after the user's name. I can just tack on, using concatenation, a period at the end. So there we go. We got a period at the end. And we saw last time that we could insert a blank line by just doing this, creating a string with nothing in it. So now there's a space after the welcome message. Little note, there are a couple ways to do this inserting of new lines. This is just an easy way for us to get started. Let's also add Writeline here. To kind of space things out so that all of our variable stuff is in the middle with space around it. And one more wrinkle that I want to show you is that you don't have to do what is called the declaration and initialization in one line. So this half of this line of code is called a declaration, where we're declaring, hey, we need a string variable called quote of the day. The right-hand side of this equation is the initialization, where we're saying quote of the day is equal to this string. So you can separate these. We can say string message with a semicolon at the end. So we've declared that variable without actually filling it with a value. So this is called declaration. Create the variable without giving it an explicit value. And then later on, we can initialize it. Let's call it initialization, putting the first value. Oh, why did I put a semicolon at the end of this comment? So we can just say message equals something like, hope you've enjoyed this weird app. And then we can console.writeline message. Give it a play. And we can see that printing out. Hope you've enjoyed this weird app. So we will often do this declaration and initialization in one line, but you don't have to. Those can be separate lines of code. We could also make this a little bit more unique here. We could say, hope you've enjoyed this weird app, comma, and use the player's name. So let's do that. Let's, instead of setting this message to just this one string, we're going to concatenate in here the name variable from earlier. And then at the end, we'll add a period or an exclamation point. Mike, welcome, hope you've enjoyed, comma, Mike, and looks like I forgot a space here. So I'm going to go back and fix that. This concatenation is just going to jam these things together without adding any spaces. So we have to account for those spaces. So if I want a space between this comma and name, I've got to come in here and add it myself. Hit play. Let's give it a run. There we go. So I'm going to end this here. This will give you the foundational understanding of what a variable is. So we've talked about that it stores data, it allows us to manipulate data. We saw a couple of examples. We saw integers, doubles, strings. There are more. I'll make sure that this reference is available, which has the list of the other built-in types in C#. We're going to get a lot of mileage out of int, double, string, and then later on Boolean. So this will serve us well, this demo, for the different types that we'll be using in this class. And in future videos, we'll dive deeper into, using these variables. So how can we create a value like the player's score here and then keep incrementing it over time every time the player does something right? So those will be coming in the future. But for now, you've got the basics of variables.